All right, in this we're going to be finding the volume of spheres. And the formula to find the volume of a sphere is 4/3 times pi times the radius cubed. So in this first one we're looking at, we have a diameter of 18. Now, we need the radius. So in order to find the radius, what we're going to want to do is divide that by 2. So diameter of 18 means that the radius is 9 meters. So let's plug in our formula. We have 4/3 times pi times 9 cubed, which gives you about 3,053.6 cubic meters. And I just got that straight from the calculator. So the next problem says that Randy's basketball is in the shape of a sphere with a maximum circumference of 29.5. We need to find the volume. So from the circumference, we should be able to find the radius and then just plug it back in, because of course you remember that circumference is 2 times pi times the radius. So in our case, we have 29.5 equals 2 pi times the radius. So what we need to do is we just divide by 2 pi. And that will get us a radius of 4.695 inches. And then all we have to do now is to find the volume. We do 4/3 times pi times the radius, which is 4.695 cubed. And then we use our calculator and we get about 434 cubic inches. These two problems deal with Cavallari's principle, which basically means that if you have the same cross sections going up the figure, like, if you look at each individual cross section, then the volume is going to be the same. Or to put it more colloquially, then if you have like a cylinder like this, if you slant it, as long as you have the same area, the base, and the same height, then these two things are going to have equal volumes. So with this one, if you look at it, Sue thinks they have the same volume. So here, let's take a check. We have the same height. Good. So same height. That's important. And both bases are circles with radiuses of 5 meters. So they have the same area of the base as well, which means, yeah, Sue is correct, because they have the same base area and they have the same height and it's the same general shape. So again, same idea with this one, using Cavallari's principle to explain why the volumes of these two stacks of quarters are equal. With these, we have the same cross sections for each one of these. We have the same base areas and we have the same height. So that's why the volumes of these two things are equal.